So hi, and welcome back to another Æther physics. Today I wanted to talk about magnets and electrets. Most of you are probably already known with magnets. They are these small things. Well, they can be big of course, but it is a conductor, and for some magical reason they tend to find each other and stick together. Well, you know the deal. It's nothing new for you guys. Magnets are well known and well used, for instance, in compasses, and we use magnets to generate electricity and stuff. But most of you don't know that electrets are around. Yeah, I want to talk about the magnets and the electrets. I wrote something down on the board to remind myself what I'm doing. So yeah, let's just start at the beginning. How do we create magnets? We create magnets by melting some conductors, for instance iron or nickel, or I don't know if nickel, these are neodymium. What they do is they melt the conductor. Well, the conductor is molten, you conduct electricity through it, and it's very important that you conduct a high amperage. Yeah, that you have high amperes. But yeah, while it cools down and when you have the electricity on it, it started to get magnetically charged. And the same idea, same principle is applied while creating electrets. Okay, so what is a magnet? A magnet are a bunch of particles together that have a magnetic field around them, and they are lined in order so that they have a magnetic field together. The permanent magnets create a permanent magnetic field around it. And the same thing can be applied with insulators or dielectrics. The dielectrics are, for instance, Teflon or plastic or beeswax, you know, beeswax from the bees. In order to create a permanent electret, we need to melt a dielectric first. So, for instance, the beeswax or Teflon or something, and when it is molten, you have to put a plate to the left and the right of it, so from left to right or up, top down, it doesn't matter, but between the plates you put the molten dielectric, and you charge the plates with, for instance, 6,000 volts. So it's not important the amount of amperes, it's important the amounts of volts. And while you have the volts on the dielectric, you cool down the dielectric until it's not molten anymore, but it's a solid piece of dielectric. So we have two plates, and between the two plates you have a molten dielectric, and this molten dielectric is gonna solidify. Between the two plates, the plate left and right, there is a potential differential of the voltage. So that means one plate would have, for instance, 0 voltage, and the other plate would have 6,000 volts. And between the two plates we put the dielectric, and the dielectric solidifies. And it solidifies when it cools down. And when it has cooled down, you get a permanent electric. And a permanent electric is very interesting. I don't have a permanent electric because I can't find one and I can't make one myself because I'm not that handy. I'm more of a theoretical person and not of a practical person. So whenever you see me doing practical research, man, that's nothing, man. I really suck at it. But yeah, you create an electret. And an electret, well, it's permanent statically charged. Static electricity is in voltage, where, for instance, magnetism is in amperes. And so it's a pretty interesting thing that you have two different kinds of magnets, electrets. But the electret is not very known to people. So whenever you search for electrets, you won't find a lot of things on the internet. I have found a video once with somebody making permanent electrets out of beeswax and doing some experiments with it. And magnets are so well known that everybody can buy magnets everywhere, and well, you know how they work. Why is this so interesting that we have permanent electrets? The permanent electrets are very interesting because they use them in, for instance, microphones. So you have electret microphones. They use a small plate of the electret, and the electret, what it does is whenever it moves close to a conductor, it creates a voltage. So not amperes like a magnet would do, because if you move magnets in front of a coil, you create a current. And the electrets can't create currents. The electrets create a potential in your conductor, and the potential is in voltage. So very interesting that you can create voltage but not amperes with electrets, and you can create amperes and not voltage with a magnet. Well, you can create voltage, but the voltage depends on the movement of the magnet. And I don't know that much about the electrets yet, because I can't find a lot of information, but I'm gonna check this paper and I'm gonna read. It will be a recall that a typical procedure for producing an electret is the following. You have two plates, plate A and B, and they are supported in a suitable molten dielectric, for example beeswax or Teflon. Plate A, plate B. We say that plate A has 0 volt and plate B has 6,000 volts. And between the two plates we have the molten dielectric. With red I denote the molten dielectric. So you have a plate A, plate B, and after it was molten and solidified, you can remove the plates and you keep your permanent electric fields around the electrode. Same principle applies to magnets. Plate A, plate B. We have plate A 0 amp, and plate B can have, well, I don't know, for fun let's use 6,000 amp, which is a lot, 6,000 amp. You put your electric conductor between, for instance, well, iron. Iron can be a magnet. You melt the iron, you charge the iron, and then it solidifies and you end up with a magnet. How can you destroy a magnet or an electret? By raising the temperature. We've had the two plates. We remove the charge in voltage, the voltage charged plates, and we end up with a permanent electret, and we end up with a solid electret with at its edge a minus 3,000 volt. Interesting fact, huh? So I didn't want to use a lot of formulas because I don't like using a lot of formulas, because these formulas are hard to understand, and most of my viewers are just here to hear about the Æther. I think in my next episode I'm going to talk a little bit more about the Æther. We're going to wrap this up. I think there was a lot of information, a lot of cool things. Yeah, what else can I tell about Electrets? I don't know that much about Electrets. Do you know a lot about Electrets? Because Electrets are kind of new to me. I know a lot about magnets. I got a lot of magnets. I use them for my board a lot because, yeah, I think it's an iron plate. Let me just wrap it up for today. Thank you all for watching, and I hope you learned something new today, and I hope to see you next time. So thanks a lot for watching. See you next time.